Okay, everybody. Now we're going to jump into a really cool co-presentation with Michael Conlin and Soyini Taylor. For Michael Conlin, after 2 years as the first chief data officer at the Department of Defense, he transitioned into becoming the first chief business analytics officer at the DoD, where he led that division till I believe it was just a couple of weeks ago. And Soyini Taylor is an enterprise data architect within Vodafone's business's technology function. She has spent her career building data transparency within organizations and helps people speak the language of data and develop an understanding of data's importance and impact. And to be discussing how data science and data architecture can work better together. It's based on the paper that they did. It's a must read. I'm sure they can give you information on how to get that. But for today, everyone, please join me in welcoming Michael Conlin and Soyini Taylor. Guys, go ahead and take it away.
All right. Good.
Hello.
Hi, good morning.
Good morning or good evening.
We're good evening.
All right.
Yes. Hold on. I just got your support staff on the other line, Bobby. I need to tell her I managed to get in the right place. So I managed to get in the right place. We're live. Thank you, ma'am. All righty. Golly gosh. Don't you just love it when technology actually works? All right, so Bobby, I apologize, and Soyini, I apologize for being a couple of minutes past due. Did you give us introductions, sir, or do we need to introduce ourselves?
No, yeah, I gave brief introductions for you guys. You're welcome to add to it, or you can just jump right into the fantastic content that we're expecting.
All righty, well, let's jump off. Soyini, do you want to lead us into the first slide?
Sure. All right, so we started this paper with the idea of not only collaboration, but also understanding what were the hallmarks of data that are important to data science. Because I think that was one of the first questions I asked Michael. I said, well, I, as data architecture, of course, can help you in data science, but what is actually important? What do you actually say is good data quality for you to be able to run all these AI models and algorithms and all that fun stuff? What do you need that data to do and be? So we narrowed it down to this list, which I've affectionately called VOLTIS as an acronym. But the most important things that we've kind of seen, or not even kind of seen, the most important things are whether the data is visible, it's accessible, understandable, and by more than one person outside of your actual department or team is also useful. As you can know, there can be a shared understanding amongst a team, but once you take it to your department or to another company, it means something totally different. Whether that data can be linked, because I'm sure as with a lot of AI, that data needs to be linked to get that answer to whatever question's being asked. Is it trusted? Is it interoperable? And is it also secure? So this actually comes from a version of what a white paper I read is called Beyond Accuracy, what data quality means to data customers. And it was written by two professors, Dr. Yang and Dr. Strong, but they started with a list of 20. So imagine we were able to narrow it down for our usage to this small list, but yeah, they started with quite a long list.
Let me add to that.
Yeah,
I think there's a couple of these that merit additional attention. Linked is particularly important to me because so often you'll get a data set that exists in isolation, and to a data practitioner, there's a rule of thumb. There's no truth in data. And the reason for that is, unless you put that data in a context, typically in a business context, you don't know how to evaluate it. You don't know what to do with it. You don't literally know what it means. And so linking is a really important element, a hallmark of good data quality. And I think we can all get visible, we can all get accessible, because if you can't see it and you can't get to it, obviously you can't use it. Linking maybe needed that little bit of an extra explanation. And these hallmarks are so powerful that if you read the Department of Defense data strategy that was recently published, when we developed that inside the Department of Defense, but we concentrated on exactly these hallmarks of data quality. So you'll find literally this actual list embraced by all of the chief data officers in the Department of Defense and written explicitly into
Wow.
the data strategy of the department. And so not only did Soyini, in fact, pioneer a viewpoint here, but we can see a large number of data practitioners who have embraced this kind of viewpoint and thrown their weight behind these hallmarks of good data quality. And that's useful for all of us, because when you're dealing with the real world of data, you've got to speak the same language as everybody else. And this is the kind of language
Yes, you do.
that the data practitioners really love. Now, you know, when we published this paper, we got really a quite entertainingly large number of views on LinkedIn. And we got an entertainingly large number of people who thought they knew better than we did, who had a different list or wanted to take one out or add one in or whatever, which is itself a remarkable accomplishment. Very few people said the list is no good. Very few people
Sure.
said we got to start over. Most people said, yeah, I might add something, or I might take one thing out, or I might combine two. But largely, we saw the community of data practitioners in that professional space on LinkedIn falling in line behind this and endorsing this way of talking about good data quality. And that's important to all of us. You know, it's important in particular because as we work with our executives, the folks to whom we're trying to give answers, it's important for us to have a common vocabulary for discussing with them what good data quality looks like, because in the end, they want to make a decision on the basis of what we present to them. And that means we need them to be mature, sophisticated consumers of data. We need them to be able to
Absolutely.
judge good quality. And so having that common vocabulary for talking about what is good quality, how do I know what good quality is? I think that's a valuable thing for us to have and a valuable thing for us to discuss with the executives we support. What do you think, Soyini?
Very much so, very much so. Because I know in my day-to-day, mostly I'm dealing with, of course, whether it's visible, accessible, understandable, but a lot of the time we're dealing with whether the data is trusted and whether it can be moved in between systems, interoperable. That's a lot of where our knowledge or our day-to-day sits, because we're saying, okay, we have it in application A. Can we lift and shift and put it into application B? And the most of the time, the answer is no.
That's right.
So you really realize how much a common business language or even a common data language is needed when you're trying to say, I have a sales system. Now I want to send an invoice, or I want to do my accounts receivable in Oracle or whatever other system. But these two systems don't speak the same language. How am I supposed to be able to do that? And having a person who sits there and manually types it back and forth is done. But when you have thousands and millions of records, it's not the best use of someone's time if you can avoid it. So, you know, these things, if you can, especially because a question I wanted to ask. So you were saying at the Department of Defense, they're using all of these. Do you guys grade against them to see how good or bad it's going against, whether it's understandable or linked, or is it just that it's a hallmark that you're looking at?
Oh no,
Because we're starting to look at that.
Absolutely. You want explicit objective measures of each of these elements of data quality. You want to expose them in a place where your consumers can see them. We typically have found the data catalog to be a useful place to aggregate this kind of a quality signal. And some additional quality signals, by the way, you know, timeliness, for instance, how old is this data?
Yes.
This is an important element. And yes, we've gotten to specific objective measures of these elements, and we are reflecting that both at a macro level. Do you get a red, amber, green, green light across all of these for a given data set?
Okay. So
And then when you double click in, which ones are green, which ones are amber, which ones are red, and then you double click in and you got the actual specifics of what the good points and the bad points are. So yeah, absolutely measuring, absolutely making that readily visible as part of the lineage of the data, so that users always know the quality of the data that went into an analytic, because as we all know, it's garbage in, garbage out. I do think it's particularly important for me to footstop one of the points you made, Soyini, which is on the topic of linked. For instance, in the Department of Defense, they have roughly 10,000 operational IT systems.
Wow.
And the idea that you're going to take a system integration approach to serving up answers to folks is just clearly a non-starter. You can't afford to integrate that many systems. And so the linkage and the ability to integrate the data, pull the data out and integrate the data in a separate repository space, that's a critical technique, because otherwise you have to put application modernization on the critical path to delivering answers to questions. And there's no organization that's going to welcome one more step on the critical path. So the idea of linking so that you can integrate data becomes a real accelerator to delivering answers to critical questions.
It does.
Yeah, absolutely.
It absolutely does.
And I was so I mentioned the 10,000 number for the DoD. I know of a large investment bank that has over 100,000. And
wow.
So it just gets worse and worse. Organizations tend to accumulate applications over time and not do a really good job of cleaning house. And so,
especially when you do go through a lot of mergers and acquisitions, you
right.
bring in a lot of software with that also.
That's exactly right. Yeah. So a lot of work here for data professionals, and of course, one of the key things when we get to data integration is we've got all these different schemas. Right? Those roughly 10,000 schemas, systems I mentioned to you, we looked at them. We could not find a schema that was reused anywhere for any reason. And that takes us right up against the kind of value proposition that data architects typically have, which is how do we map these things together and not have ambiguity, not have complexity in the way we define our data. And that, I think that was, for me at least, one of the really interesting parts of our collaboration around this particular challenge, because you came at it from an architectural viewpoint and I came at it from a practitioner viewpoint. And it's all about resolving that fundamental diversity or heterogeneity of data.
Yes. Absolutely, because it's just like the question of when you have a customer in each application, but is it the same thing? Right. Is a pen a pen? Is it a pencil or something else? Mm-hmm. So yeah, it's one of those very hard questions that even if it is the same language, you almost have to say to yourself, is it really? In some shape or form. So yeah.
Right. And especially in international organizations where the term dollar is a great example. Is it a US dollar? Is it a Canadian dollar? Is it a Hong Kong dollar? Is it some other kind of dollar? There's all this ambiguity.
And as in the world of data, that's the world we live in, constant ambiguity and trying to find some clarity out of that.
Yes, indeed.
This is a good one. The 80% of data science is wrangling the actual data, trying to make it play nice.
Yeah, so let me go through this one a little bit, if I may.
Yes, of course.
Because I've had data science teams reporting to me, and this is their day-to-day life, and it's the day-to-day life of many data practitioners. It kind of starts with somebody asking a question, and you got to go get an answer for them. And this is, once you've got the question, these are the steps that you typically go through. So now imagine you're at the Department of Defense. Which of the 10,000 operational IT systems has authoritative data to answer that question? And by the way, the topic of authoritative data is actually defined in law. We have this thing called a system of record notification that says, to make this decision or answer this question, for this purpose, you must go to this source. And therefore, looking for data means combing through 1,000 system of record notifications, public documents, or talking to a lot of users because it's a highly complex organization. And so just finding what sources that we're going to go to is a challenge. You go looking for it, maybe you find it, and then you have to persuade the owners to let you access it because, again, in that environment, the data owners are running their own applications in their own data sets in their own data centers, and you have no user privileges in those places. So you have to get their permission to get in there, or you have to persuade them to give you a copy. Then you've got to bring it all together. That step 3, standardizing, cleaning, getting it into a common set of vocabulary and measures, adjusting for 4 or 5 different date structures as an example, geolocation code examples and so forth. There are places where you might have 2 different systems used in, let's just say, targeting that use different GPS structures. And, that could be an interesting exercise in cleansing data, because if you don't resolve those differences, you have some issues. And then you start with number 4, you're putting it together and you're integrating it and you're trying to create a comprehensive view. This is where you begin to link to context so that the data becomes meaningful. Then typically is where the start of data science really creeps in. You're starting to go through the data, figure out what's statistically significant, where the patterns are, how they relate to one another. And you might run 2, 3, 4, 10, 15, 20 different statistical algorithms over the data, trying to figure out which data features are revealing a pattern, and what kind of pattern they reveal, and what that means about the shape of the reality. And sometimes you go over and over again, trying really quite in a desperate search for things that are meaningful. And then maybe you don't actually get there. Maybe you get to step 6, where you begin to tear your hair out. And as you can see, I've done that part. and then you start over again. And this is true not only when you're dealing with unstructured data, like images and videos and text, but also even when you're dealing with structured data. There's a real effort that's behind finding the meaningful patterns in the data that you can statistically validate. And so often you'll go through this loop a number of times. And there are shortcuts. You can use the so-called unsupervised learning tools to run through a number of the iterations on your behalf, looking for sort of the most common kinds of patterns. And they can really help. They can take a lot of labor out. They can take the first 2 to 3 months of effort out of a project, because steps 1 through 7 cycled several times can take 2 to 3 months. And so that's a really valuable kind of accelerator to have available to you. But even with those tools, fundamentally, because you're doing applied R&D, and that's really what data science is. It's applied research and development. You're experimenting, you're trying different things, and you're working to figure out what's in the data. And that's why you see this pattern of 7 steps. And that's why on any new exercise, 80% of data science work is actually wrangling data. And here's the fun part. Once you get successful with a given set of data and you answer this given set of questions, everybody says, that's great. That was yesterday. What are you going to do for me today? And you start over with another set of data and another set of questions that you're trying to answer. And you're always moving into new data. And so you're always back in this phase of 80% of your work is actually trying to get to the point where you know what you can do with the data.
So that basically, just like in the paper, we were talking about, especially with this, that means that there's tons of experimentation.
That's right.
While looking for, and tons of failing fast, if you will.
Oh, yes.
To get to that, I don't want to say right answer, but proving the hypothesis, I guess, in a way.
Well, you want to get to a useful answer. And
yes.
And yes, and you need to celebrate the iterations. You need to be okay with a number of experiments, because the reality is all of us, all data practitioners, even the experts, maybe especially the experts, we're making it up as we go along. We're actually trying to discover what's in the data. And so there's a real element of improvisation.
Very much so, because it's like, I was just thinking as you're speaking about this, it feels like in a way that you're building a structure that you can rip down and put it back up again and rip it down, where I feel like data architecture for me, many ways, I feel like I'm building a brick and mortar building. You know, I'm trying to put proper cement in there and more bricks. And then whenever someone says, that's not actually what it is, you're like, oh my gosh, how do I break this down so I can rebuild it? You know, there isn't, not saying the flexibility is not there to, you know, have something you tear down and build back up. But when you start to learn about data architecture, a lot of it feels like brick and mortar.
You know, it's interesting you say that. That's been my sense as well, that you start with an intent for a structure, and then you flesh out that intent in some detail and you build it. Whereas in the data science space, it's about going to search for a structure that may be hidden in the data. So you aren't assuming you're going to start with a structure. You aren't going to implement a structure. You're going to try to find it, which feels like the opposite of the world of a data architect.
Yeah, and see, this is why I've been so interested in collaborating with data scientists, data analysts, and things like that, because I realize that whenever I go into a project or a new environment, my tendency is let's start putting the bricks together and get this solidified thing. But what I can learn, I definitely know from data science is that, and the data analyst is basically that we're building the structure as we're going along, and the structure can change, and that's okay.
Yeah, excellent.
And that's okay. So it's one of those things where I'm realizing if everyone works closer together, of course, then as the data scientists are discovering, data architecture can be discovering, and everyone can discover together. So that way this structure doesn't become this hard and fast thing that can never change. It becomes this thing that's moldable, and you can keep going in that direction. You don't have to worry about, oh, I have to rip this down today and build something else totally different tomorrow.
Right. Excellent.
Yeah, so this is just going through the percentages that proves that, you know, how much of the time is spent wrangling that data, 60% cleaning and organizing.
And you know, this was a really great graphic because it provides, it's actually based on survey data, survey data that's been statistically validated. And there's a tendency when you see a statistic like the one we had on the prior slide, 80% of the work data scientists do is wrangling data, is to interpret that maybe as an opinion, to interpret that as a characterization rather than as something with factual substance. And there is real factual substance behind this. These kinds of activities, these kinds of work you see show up in surveys of data scientists over and over again. I think it's worth touching on one or two of the terms in the diagram for those of you who aren't data practitioners. One of them is building training sets, that's training data sets. The challenge with machine learning and AI is that you're going to take an algorithm and you're going to train it on a bunch of data. And that means that you need really good quality data that's been statistically analyzed and proven to be a valid and accurate representation of the real world, because otherwise data is a mirror image of the people who collect it, meaning it'll have all kinds of biases in it, all kinds of absences in it. And so getting to what's called a training quality data set is a significant exercise. And for many data scientists, it's a significant emotional event. The results are unique to the organization. So this is an incredibly valuable asset in your enterprise, one that you're going to want to make sure that you are protecting. Now, you don't get to that state of building training data sets without having done many of the other things in this list. They are precursors to building the training data sets. there's once you've done the collecting and the cleansing and the organizing, you have to do this statistical analysis, and then you have to separate the training data sets from the training data set from the testing data set. So you split this big group so that when you train the algorithm and you project results, you can then go back and apply the test to it. Building training data sets is a really big exercise, really important for data practitioners, and the kind of thing that business users do not care about at all. That's not something they generally have visibility to. And so we have to educate them that this is an important asset and an important set of capabilities. And you see, while I didn't try to do a one-to-one mapping between this diagram and the prior slide was more of the how it feels when you're doing it. And this is more of the step-by-step that you actually go through.
I just wanted to pick up on what you were saying there about the biases and all of that, because I've been doing some work with the TM forum, telemanagement forum, on model sheets, fact sheets that everyone's doing to log biases, explainability. If you were to say, for example, if someone's up for a mortgage in a place like New York, what would their rates be versus someone who's in a rural area in another part of the US, or maybe in London or wherever? How much of this time would you just say off the top of your head would be documenting what you do while you're doing it? You know, the kind of where you got your training data from, what biases could be within that data, and how viable it is if you decide to change out some of the information like location or age or gender or whatever have you, that may send that AI model running for the hills, kind of, so to speak.
You know, I'm not sure that there's an easy rule of thumb for that. It's a really good question,
Okay.
but I'm not sure we have a really good rule of thumb for that, because it tends to be quite specific to the data set. I mean, let's take your example. If we were to look at real estate deed data in Dayton, Ohio, what we would discover is that there are developments and communities that are where in the 70s and 80s they built all these developments, and they put language in the deeds that said no person of color can own this property. Literally, it says that kind of thing. And then there are other places where they didn't say that. You have to get down to the track level to find those patterns in the data. And it's not always the case that it'll be in the actual real estate system. You have to now map it to census data in order to be able to see the relationship between the demographic and the geographic. And that's when the biases are revealed in that sense. Survivor bias is another challenge. So those of you who are familiar with that, you're looking at a different kind of data, and you're typically needing to join multiple data sets to do that. There's a lot of judgment in those exercises, and perhaps I should say subject matter expertise. If you don't know the domain, you're not going to be as successful. If you don't know the data types specific to that business domain, you're not going to be as successful. If you don't know the algorithms specific to that business domain, you're not going to be as successful. And that mix is very different from domain to domain. And so the effort is difficult, I think, to characterize in a quantitative way. I hope that's still a helpful answer.
No, it very much is. And what you were just talking about, where you're saying if you're not familiar with the domain, then it can almost be like trying to understand another language in many ways. And it very much is, especially for data architects, because say, for example, right now, we say data is data, but at the same time, if it's going to be cataloging stars, I may not know as much about that, of course, or if it's maybe cataloging genes or something like that, or the chromosomes or something like that, or whatever is, or our genetic makeup. I may not have as much knowledge about that, but then as far as if it's a router or a cell phone or something, I've been building up that knowledge. So it really is trying to get a base level of knowledge in each domain to be able to be effective.
That's right. And the reality is that while we can accelerate the rate of learning around coding Python, we can accelerate the rate of learning around statistics, there simply is no good compression algorithm for subject matter expertise in a business domain.
Yep. Absolutely. Absolutely. So this one is where we're talking about in the white paper of how people, the process, and the technical products need to work together.
Yeah.
I'll just say for this, while I find the products can be useful and the process that is used to you not only collect your data, but how you're going to use it, I think the most important part of the puzzle is people. I find a lot of times the blocks to getting data understanding and data knowledge can have to do with cultural change within an organization, whether it's, silos, it's just the way it is, or we are somehow going to today actually reach across the aisle in many ways. And Department A is going to work with Department B, and it's not going to be a matter I have to hoard information or hold on to information, or your data needs not the same as my data need. So
Yeah,
there's no
completely
need to
agree.
collaborate.
Completely agree. It all starts with people. That's why we put it the 12 o'clock position on this. If you don't get the people aspects of this right, if you don't deal with the cultural aspects of this, the enterprise culture, it doesn't matter what you do with processes and products, you're going to struggle. And people are the really important element of this. In fact, I think it's worth touching on that just a little bit longer from a personal perspective, Soyini. Maybe we should spend a moment talking about how we, as two people with two completely different career paths, working in two completely different enterprises in two different countries on two different continents, ended up collaborating around this paper.
So yes, okay, sure. So for disclosure, so everyone knows, I'm based in London, even though I don't sound British in any shape or form. But I am from the US. I reached out to Michael because I'd been reading his first 90 days as a chief data officer papers. And a lot of what I've seen while I've been a data architect, everyone talks about analytics. Everyone talks about data science. But the data management parts that come with data architecture seems to be left out somehow, some way. So my first instance to reach out to Michael was to say, how do you see data architecture fitting into this puzzle? Because the amount of time you spend wrangling data, if you have someone like a data architect there to help structure that data or help you understand what that data means, or be a person to help with the legwork of figuring out, we have 5 different definitions of a customer, but overall, our customer is a person who not only buys something, but has a contract, and the contract's been signed. So that's basically the short version of how our collaboration started. And through many emails and a few phone calls. And while we were having our conversations, Michael said, what do you think about putting together a paper? I was like, what? Most definitely, of course.
Yeah, and I was the fortunate beneficiary of your initial contact. One of the things I know from being a data practitioner is that when you get a diverse team, people with different backgrounds, people from different places, people with different viewpoints, you get vastly superior results. The insights you derive are more statistically valid and accurate, and they're more useful. And so when you reached out to me, my initial reaction was, oh my goodness, no, not a data architect. No, we don't want any of that stuff. And then my second thought was, well, hey, wait a minute, that's a completely different viewpoint. So let's bring that into the mix of things and let's benefit from that alternative viewpoint. And then I think we were able to develop over the course of our dialogue, I think we were able to develop a collaborative approach that brought together some of the great contributions data architects can make to data practitioners and vice versa. And I think that we brought to reality that idea that the diversity of opinion, it creates far better analytics and far better insights.
Absolutely, because even in the conversations I'm in, a lot of times I find people will say, well, what can I as a data architect bring to the puzzle?
Sure.
But I'm always saying you're wading through a data swamp in many ways. I can help make the water clear. I
Yeah.
can help you see what you have. But it's getting invited, like it even says in the paper, how do we get the data architects invited to the party? And sometimes we're left on the outside trying to reach over the fence, like, we're here, we can help, but not all the time are we able to get that seat at the table to say, here we are. We have a skill set where all we do all day is talk about business language and making sure it's common and structuring it and linking it.
Yes,
That's
indeed.
what we do. So we can definitely help. Yes, we do need to get better at moving a little faster. We're a bit of a, toad, or not the toad, what is it, turtle? And the hare, we're a little bit of the turtle. We're kind of a bit slow in some ways. But I will say that working with more people that are outside of data architecture has made me speed up what I do. Because you see another way of working. So, working with data scientists, working with data analysts, it's made me say, okay, I don't have to draw everything. I don't have to diagram the universe today. I can diagram a city.
Excellent. All right. So Bobby, is this when we transition to the question and answer portion?
Yeah, I think we're kind of at a hard stop in about 30 seconds here. So
Oh,
yeah, apologies for that. So yeah, I think we had the technical difficulties in getting in. Unfortunately, is kind of what slowed us down a little bit. But I'm sure everybody will check out the paper. So I don't think we're really going to have time for any questions.
Okay.
So again, apologies for the delay in getting started. But we are due to the next session being a recorded one. We are at a hard stop now.
Okay. Well, thanks for the
I understand.
opportunity.
Thank you
Oh,
so
no,
much.
no.
Really appreciate it.
No, thanks. Thanks again for all the information regarding the ways that data science and architecture can work together. So appreciate your flexibility on the start and end time. So on behalf of everybody here, thanks again for joining us, guys.
Cheers.
Cheers.